everybody, and welcome to This Week in Innovation. On today's show, Brian and I talk about Marc Andreessen's famous essay published in the Wall Street Journal on August 20th, 2011, Why Software is Eating the World. We talk about the history of software development, look at where it is today, and we project where it's going forward. And of course, we're going to be talking about low code. Give it a listen and let us know what you think. Hey, Brian, how you doing today?
Doing great, Jeff. How are you?
I probably ate a little too much candy this past weekend, but other than that, I'm feeling.
We've all had that problem. I think if you have a service that would take Halloween candy back.
That is something that there needs to be a startup that comes to your house about 8:05 p.m. on Halloween night and take the candy, because unfortunately that bag is still one of the bags is still in the house. That's a really good idea, Brian. I like candy as a service. Speaking of eating, 10 years ago, Brian, Marc Andreessen wrote that famous Wall Street Journal article, Why Software is Eating the World. I'm curious, now 10 years later, what do you think about that? Where are we with what Marc was saying?
I think that it's a very interesting question, Jeff. I think a lot has happened since then. And I think there's a really interesting quote from what Fred Wilson, the very popular venture capitalist from Union Square Ventures, once said. I think it's been said by many people. I think Bill Gates said it previously as well, which is like, people always overestimate what can happen in a given year, but underestimate what can happen in 10 years. So it's almost 10 years since that quote came out, and lot has happened in the software industry. I think we've come far away, especially with low code and AI, IoT, all these technologies being abstracted by software. And also the ability of software propagating a lot faster in traditional industry. Because it's obvious Silicon Valley has been in this for the last 50 years in software. But now we are seeing the propagation across a lot of the traditional industry players, all the way from beauty to insurance to automotive to convenience. Industries that were very manual before, using novel uses of software, not just simply digitizing their customer touch points, but also using AI, IoT, and machine learning in a much more effective ways to understand consumers better, to understand interactions better, to manage their inventory, do a lot of different things that are super interesting, the touch points, all using machine learning. So I think software has come far away. But I also want to take this moment and talk about two interesting paradigms in terms of evolutions. The first paradigm is basically the software evolution stack, which I call it. A lot of different leaders have spoken about it in different ways. What happens, what the stack means is it explains how software has evolved over the last every decade, how it has evolved. In the 90s, we've had packaged software. So there are so many companies providing like Lotus Notes and all these companies providing software that was packaged software. You go into a software shop and buy packaged software, and even digital versions of packaged software. Or the early players, Oracle and many others, provided packaged software. But then time passed, the installed packaged software on the layer 2 or the next evolution became SaaS. In the late 90s, it was called application as a service or application software for rent. That's what it was called. But over time, it became software as a service, where customers did not own the software, but they took advantage of the software that was hosted and running in the servers of these software providers. So that SaaS paradigm is still there. A lot of our software that we use every day, if you even at our own company at Iterate, we have over, 30, 35 SaaS vendors we use on a regular basis, all the way from accounting to software development everywhere throughout the different parts of the organization. If a traditional organization probably uses in average over 100 vendors, or SaaS vendors, providing different parts of software across many different buyers of every department. But then the third evolution is component software. So now what happens is it got more granular. As any industry evolves, things get more granular. Just so the component software is essentially like a supply chain mechanism. So today, if you're looking at a car, there is a manufacturer, there is a tire manufacturer who makes the tires. There is another manufacturer who actually does the stereo system. Another one that does the doors and the interior. Similarly, for software, there are very specialized software manufacturers, like Twilio is a classic example. They provide communication software and component software. In the AI space, there are a lot of players who provide AI recognition capabilities and various software components. So that is the third evolution of software, where everything is componentized. There is somewhat of a virtual supply chain mechanism. And that as engineers and then leaders within companies, as they are putting out these digital initiatives, they assemble software across these paradigms. That's the paradigm. So today that is the paradigm that's in action today. Between that and the older SaaS, those are the two kind of paradigms that you see in action today. You don't see very many packaged software anymore. But then the paradigm that I'm going to talk about next, the fourth evolution, which is going to be the self-organizing, self-writing, software generating software. Not just humans generating software, but software generating software. I think with the growth of and stuff that's happening inside machine learning, we are not far away from that. We are already seeing in a lot of areas where code is being generated. This whole idea of code being generated has been there for years, right? They use traditional methods to generate, but that's changing now with machine learning, where you can generate code for different interfaces. All you have to tell the machine learning system is, I'm interested in this type of an app that will interact with the customer this way. And these are the features I like to have, and then click on a button and it will generate code. Or a designer could design a user put all the buttons, click all the actions, tag all the things that he wants to do, and say, generate code now. So this generation of code, I think, is interesting. And also machine learning, ability to doing machine-driven code generation, machine-driven DevOps are going to get very interesting. Because I think that thing is probably the next paradigm that we'll begin to see. So that's one dimension of the software stack or the evolution paradigm. There's another dimension, I think, which is very interesting. The software can eat the world only when software has the tentacles. Because software is like the brain. The human has the brain, but without your arms and your body, you can't really put a lot of your thoughts into action, and it's very hard. So in the old world, we had keyboards and printers. There are input tentacles and output tentacles for software. In the modern world, we have visual, we have, touch screens, we have multi-touch, we have all kinds of interesting interactions with this type of virtual reality, AR, interactions through bone conduction, through glasses. So these are all new tentacles. From a human-computer interaction, we are getting newer and newer tentacles with VR, it's brain devices, brainwave sensing devices, all that type of stuff. The different traditional industries are also getting different tentacles. Let me give you a classic example. In the beauty industry, in the olden days, if you were to do a makeup or a lipstick, you have to actually go get that lipstick manufactured, right? Then in a manufacturing facility. Now that manufacturing can be done in a small lab as micro manufacturing. But there are so many startups and companies working on where you can set the color of a lipstick or set the color of a makeup or a foundation, and it can be built for you out of the gate. Because this is a tentacle that takes the color combination in the software and turns the software into actually a piece of. So these are the type of tentacles. In every industry, you're finding tentacles like this that is specific to the industry. So as software is getting powerful, powered by tentacles, hardware tentacles, which are becoming cheaper and easy to reproduce. So that's another dimension of why software will eat the world. First is that software has the evolution power to conquer the world and convert everything that's digital and everything that can be done via a human process via software. Second is software is getting arms and legs, powered by these tentacles, which is powering software to get even stronger and to do more things that we have not imagined, would have not imagined 10 years ago.
So that's really an interesting way of thinking about that. I assume you're making the case that these tentacles are really almost IoTs, very little devices that are connected.
Yeah, absolutely. They are IoTs, they are industrial devices, they are even non-internet connected devices too. They can even be like non-connected devices, but they're connected to the software on that edge, on that case. Yeah, absolutely. Yeah.
So we're well into the service. I'm not sure we're really, you'd have to tell me if you can really even come up with a couple of good examples of self-writing software. So where are we in this evolution now?
See, I think where we are, Jeff, is we are in the maturity of SaaS. SaaS has been very good. And then venture capitalists, investors, startups, the paradigms around SaaS, how to build a SaaS business, how to attract consumers, how to drive traffic towards it, how to optimize it, how to deliver the service has been very well understood. So we are at the very top peak. And then what's going to happen? So we are in between the 2 and the 3, which is component software. So there are a lot of software today that's being written is being built by frameworks and by using components. But what happens is only a very few companies have been very successful in becoming component-related software companies. But that will change. But one of the things to realize, though, is if you look at the open source movement, in their entire world, everything is component software. The open source is all about taking a framework or a component from here, taking another thing from another place and assembling. So I think we are in between the paradigms of SaaS and the component software.
So is component software, is that low code?
No, I think component software is more broader than low code. Component software just simply means once one part of the software, not all the software is provided by one company. The software has many different functions. And for some of its functions, it's using software from company A. And for another function, it's using software from company B. And they are either licensing these individual pieces of software. And as a software developer or as a traditional organization or a Silicon Valley company, you're putting together these disparate pieces of software. And the place where you're building, the dock where you're building all these, assembling or putting together these pieces of software is the local platform.
Oh, interesting. So we used to call that just a best of breed strategy with a whole lot of SIs doing all the integration work. What you're doing is we're still talking about a best of breed strategy, but massive savings around the integration costs on a local platform.
Absolutely. Massive savings around the integration cost. And also every different player or the provider for the component software, they are experts on those things. So they've given you the best of breeds. And all the best of breeds are abstracted in your low-code platform. So you can, just like moving Lego, you can move these things and try to connect them and start building software and taking them to market a lot faster, right? So that's why the low-code, no-code world is very interesting. But what's also super interesting, Jeff, is as you're having this no-code, low-code capability, the apps or the solutions that are built in no-code, low-code is essentially solutions that are built by connecting the disparate blocks or software components. So because it's easier for any developer, even without a lot of training, being able to manipulate this type of software, it also becomes very easy for machine learning systems to understand it because you have abstracted a lot of the complexities within these blocks. So these paradigms can be trained. Say you build an e-commerce platform on top of using a low-code engine. You can train the machine how to regenerate code for any e-commerce platforms in the future by just inspecting the connected paradigm of the existing e-commerce platform that's all built on top of low-code. That's why this evolution is really interesting because it's nicely teeing everything up for the machine to learn it gracefully and regenerate it.
So was that what no code is then?
So no code is very simple. No code is the difference between no code and low code is no code means when you are assembling these blocks, you're not writing any traditional programming language in the sense. You're just assembling a bunch of blocks and putting that into and building and deploying an app. You're not writing any programming language. You don't need to know any programming. So that's no code. Like, for example, the web designer, the web builder you use to build this Week in Innovation website, that is a no-code.
I've been calling that low-code, so it's actually no-code since I've literally programmed nothing whatsoever.
You don't have to write any code. So the problem with that is it's great, but it also has its limitations because when you want to do things that are more custom and deeply customize it, you have to write code.
Right.
But those platforms are designed they are single-purpose platforms. They're designed to do certain types of websites or certain types of screens. But a platform like InnoPlay, for instance, the platform that we have it's a low code platform. So you could do quite a lot of things by just drag and drop with no code. But if you want to customize and do things deeper, because most enterprise applications and enterprise activities require significant customizations. So you can still write code and customize. And the code you write get abstracted into these blocks and then reused over and over again. So then they become a part of the no code in the future.
How big is this going to be?
I think this can become very big. Recently, I was reading an article, and it's completely on a different industry by, of course, Professor Scott Galloway. He called the content creation paradigm, the Netflix's content creation, infinite opportunity, infinite in terms of scale, because people sit at home and watch content all day long, and the size of the pie is becoming very large. Same parallels is there for low code and no code. Even though the published market sizes, I think it's around 209 billion by 2024, 2025. That's the standard analyst published paradigms. But I feel these markets can become very large because it's not just about no code, low code. Just the way people have this insatiable appetite to consume content, people also have insatiable appetite to consume. Look at how much time we spend in Facebook, depending on what our age is, or Instagram, or whatever, any of those things. Like people have, consumers are sucking all these things like a sponge, just sucking the whole thing up, really. So the paradigm is getting bigger. The pie is getting bigger. I can give you like a very high level. The analyst prediction of some 209 billion by 2024-25. Microsoft made a prediction within the next 5 years. There's going to be like, I'm paraphrasing, of course, there's going to be 500 million apps are built, and out of that 450 million are going to be low code, no code. And then I think it's going to be much, much bigger. Take AI, for instance. If you look at AI, you and I have talked about this, Jeff, in the past. If you look at the AI prediction, I think initial prediction of, I think, was 180 million, 80 billion. Then it went to 300 billion. And I think there was recent IDC, one of the predictions are almost at 500. That's because it's bigger. It's way bigger than we initially thought it was. Because as these growth markets and these new opportunities are actually far bigger. And the other thing that's also interesting about these forces is this. We always talk about the 5 forces of innovation: AI, IoT, blockchain, data, and startups. These forces are not just by themselves. They are all intertwined. And then they are all intertwined with low code, because with low code, you can build all of. So they all feed into each other, and that feeding and that frenzy creates a bigger market, bigger opportunity. If you look at the digital transformation market, that alone is around $1.8 trillion. So inside that AI, with all the new latest number upgrades, it's around 500 billion. And then you have low code capability is around 200 some billion. And then you have IoT in the somewhere in the close to $1 trillion. But the thing with IoT, you have to be careful, is hardware is factored. A lot of that cost number is hardware because of the sensor. And data itself is another 160 to 200 billion. That's just because of the nature of data. And blockchain is around 39-40 billion, but that's just blockchain software, not Bitcoin, because that's in the trillion range. So you're looking at very large markets all coinciding together. And then even that large market, unfathomable large market size you're talking about, that itself, I think, is still small. I think it's very similar to the content argument. It's infinite. It's very large. And because consumers are sucking it up like a sponge, traditional organizations are doing more and more of it. And it's propagating within traditional organizations. And then, of course, as a lot of the high tech and the Silicon Valley vendors, they are doing it. And then it's also going into everyday objects and everyday things that we interact with. So it's growing in every dimension.
We in the analyst world do not have a way of calculating infinite market size. So I'm not sure what we're going to do there with that number. But I guess it's safe to say it's a pretty big space, or pretty big potential. That being said, Brian, so what do retailers do about this? When we start talking about giant market sizes, then that means some or a lot of people are doing something. What should retailers be thinking about today? And I don't know, wherever you see adoption really beginning to take off for this.
It's a great question, Jeff. I think retailers are already beginning to see this. I think a lot of retail players that we are speaking to, or we spoken to, or we have deployed solutions to, they are thinking about it. They are seeing its benefits in front of their eyes. Because the challenge in retail is a very complex industry. I mean, that's because there's a lot of moving pieces. You have the brick and mortar, you have the digital, and it's also a thin margin industry too. So you have to be very cost conscious in terms of what you're doing. And also move fast, because digital is moving fast, especially with the pandemic. The 5% digital is changed. Now if you look at companies with 15-20% of the business, it's changing faster. It doesn't mean stores are going away. They are there, but they're also creating they're all getting intertwined. It becomes a connected paradigm. So what's really interesting in retail is I think the retailers are seeing cases using low code and how quickly and how easy it is to get to market. And they're seeing its benefits. And I think what's also really interesting is retail is also about an industry, like you said. One is best of breeds. The other is reusability, right? And best practice. Because retail is good at those things. What I mean by that is they always try to figure out how to buy best of breed solutions. In the old world, they used to buy big one-stop vendors. And in the last 5-6 years, they've transformed to buying and looking at best of breed. The other type is best practices, because as you go look at NRF and all the other conferences and people attend to, the retail leaders want to learn from each other and figure out how to use the best of breed, best practices, and also to figure out how to do reusability, how to reuse. I think low code is really interesting because low code basically honors all three of. It's best of breeds because it's a dock where you can bring all the best of breeds component and build your ship. You can dry dock it a lot faster. So that's really interesting about best of breeds. The other thing that's really interesting about it is that low code allows you to use best practices because every component is a specialized component. So it's you already using best practices and you're putting together in a way where you can reuse it and it's completely reusable and anybody can change it very fast and go to market. So it's very in line with a lot of retail that's been out there for years, like the learning and the knowledge that's been around in retail for years. But let me tell you a little bit more. Let me drill down into a little bit more, like 1 or 2 levels lower, and tell you use cases. If you look at like in the auto industry in retail, retailers who are selling auto parts, auto products, auto related services, you can use machine learning to identify vehicles that come into your service centers. Really understand using vision, understand damage, understand potential problems and proactively and have that ability to proactively let the customers know of future repairs that need to be done, or even to do very intelligent estimates. You can look at a given problem and use machine learning to do very intelligent estimates. And then when you go to the store and then a mechanic looks at it, there is not a lot of surprise saying, okay, you did an online estimate and told me it's $500 to fix it. But when you go to the store, it's a $5,000 bill. That's a massive gap. How do you make that gap smaller using much more deeper machine learning? So those are really interesting cases. And as I mentioned to you previously, in the beauty industry, you want to be able to produce makeup that matches all type of skin. What if you have the ability to really understand somebody's skin tone and actually produce makeup really rapidly? And that's using maybe a device, but the remaining is all done through software and machine learning. How do you understand, based on prior skin tones, how do you understand that this given person, this would be the best message, the best color for skin tone? And that type of things, right? These are all very industry specific. Same thing applies in the convenience industry. You have a convenience store operator and you're looking at vehicles coming in and you're able to sell them at the forecourt and then do recommendations of products they would like. By you looking at people in the forecourt, you can understand what they want based on your database, based on prior purchases. You could even use their vehicle as an entry point to actually buy things. Because once you recognize the license plate, you can actually use that or throughout the entire store transaction. So there is much more intelligent touch points. It's up to imagination in terms of all what you can do. I was talking to somebody else and they were mentioning an example in the past where they've done in the postal industry, where they are able to intelligently route mail and then by just visually inspecting through machine learning. And then of course in traditional retail, we are seeing the brick and mortar, we are seeing the Amazon Go paradigm. There are so many companies inventing much more effectively using around all these paradigms. So these are all examples of machine learning and examples of modern technologies. But what's really interesting is as you want to put applications out for consumers to use it, the integrations that retailers can do can all be through low code because you can just call these APIs directly. You can connect them. You can deploy an app very fast, very quickly. I think that's where low code becomes very interesting. Go to market really fast, test things out. The other problem I think it's also really interesting about retail is retail has predominantly from a technical skill set, has a lot of engineers who are traditionally web engineers because they have to build the retail website, the commerce site. Don't have very many AI engineers. So if you look at the world today, I think there is 25 million engineers who are trained on some or the other form of web development who can build web software. But there is only about 30 or 40,000 engineers who know machine learning. I think there's about 300,000 people who are researching with academics and everything. But purely from an engineer perspective, the new numbers are around 40,000 machine learning engineers. So what happens is in an industry like retail, if you build low code where people can drag and drop all these Legos, it's an 80-20 equation. With 20% of effort, web engineers can drag and drop and build very simple systems using machine learning without a lot of deep knowledge in these systems because you abstracted all that intelligence and that skill.
Wow, that's really...
that's why it's going to be powerful in retail.
That's really interesting. So I assume the enterprise software players can fairly easily migrate into this new paradigm. They create functionality. How it's deployed on a low-code platform is probably straightforward. Relatively speaking, it's fairly straightforward. But what about the cloud players? How do they fit into this? How does AWS and Google fit in?
That's a great question. See, I think cloud players fit in very naturally into this equation. But I think what also has to happen is just like, I love your word of intentional innovation. What they also have to...
An oldie but a goodie.
I know, right? I think they have to take a little bit of intentional approach in connecting their software components to the low-code world. Much more intentional. I'll explain you what it is. The cloud providers are very much in the past. They've been providing infrastructure components like network, bandwidth, CPU, servers. But lately, they've sort of become the providers of pickaxes and shovels. Think about Home Depot. You walk into Home Depot, racks and shelves of 2x4s and tools and drillers and nails and screws and everything you can find, every component. But they're very granular components. The reason they provide that is because they want to be the building blocks to every company out in the world. So they can take advantage of volume and scale and empower the development. It goes back to a little bit of they want to be these wall gardens or these or gateway, depending on how you look at each one of them, of component software. Right? They want to be this provider, these one-stop providers of component software. So that's the paradigm where they are all going to. But the next evolution of component software is the dock where all these software is. And then not only you are putting together software in these docks, but you're also putting together, you are reselling and reusing software, existing ships that you've already. So low code becomes that dock where all these component software offered by these cloud providers can be assembled together and build software. And also it becomes a place where you get resell, where ISVs and others can resell existing assembled paradigms again in a marketplace again within their cloud capability. But I think what's also interesting is for the cloud providers, they should look at how they can do this in a very effective manner, provide these docks to their customers. Because I think the new war in the cloud space is not fought in Silicon Valley. What I mean is the Amazons, the Googles and the Microsoft, the AWS, the Azures of the world have already had their footprint in Silicon Valley, in like very tech-centric companies. So not only Silicon Valley, anywhere, Austin, anywhere in the world, but very tech-heavy companies. The next shift of the paradigm or their next market share is going to be coming from traditional organization adapting technology. But what's really interesting in these traditional organizations is, number one, they don't have a very modern 5 forces innovation workforce. They have a lot of traditional web engineers. And can you provide a dock where they can easily upskill and go to market rapid? So I think that's why they have to think about the low code and no code, especially low code more significant. No code is interesting, but I think no code is a little bit of counterintuitive to their paradigm too, because they are essentially encouraging engineers and developers to build. No code, of course, is more meant for marketing and other folks because it's not fully configured. So I think that's why I think low code platforms and low code docs are very critical for cloud players. And they have to think, I think that's where the next war is going to be fought in capturing traditional companies.
Very interesting. Brian, earlier in the conversation, and I wrote it down, I meant to get back to it a little bit earlier, but you were talking about self-building or self-writing software. You want to tell me a little more about that? That actually sounds a little scary, but I'm sure you're gonna assuage my nerves about that. What is that?
So essentially, what happens is with machine learning, with supervised learning, one of the things that's really interesting is you feed the machine with a certain set of patterns, and the machine would automatically understand and learn your pattern. And then when you give it a new set, it would basically repeat that pattern, or it could put you into a bucket and understand which pattern it was. By using methods like that, what can happen is, and it has come a long way, how do you actually use machines to look code that's been pre-built? You can have machines learn code that has already been built, applications that have been built, and you can have the machine regenerate given the use cases, and also have the machine teach the machine how things are being broken down. So you could basically go in. It could manifest in many different ways. So one of the simplest manifestation a lot of companies are trying to do is basically imagine you log into a portal or into some dashboard, and you can select, I want this application. You type a paragraph, say, I'm looking for a loyalty application where loyalty points are tracked by the system and consumers can spend and loyalty points can be transferred, blah, blah, blah. There is an interface, there's a dashboard, blah, blah, blah. You type a paragraph, a mega paragraph requirements, and say, click on a button, and the system could generate code and understand the intent of every sentence you said and actually look at it and generate code. So I think we are a little bit away from that because the software systems are very complex. I've seen companies taking a stab at that. There are startups that actually where you can go and type a paragraph and it would convert parts of it to code. But I think we are far away from that, but we are not too far away, but it can be done. But I think one piece where it's much more useful is where a designer can go into a design platform and they can go do a design of these screens of how things have to look at. And they have the ability to tag what functionality they need. And the backend for that is, and then the front end, corresponding front end is automatically generated based on all that. And then it'll also connect to the appropriate backends. Because with low code, what's really interesting is you're already componentizing everything. It's already component. And then the low code platform or the low code builder is a dry dock where all these components are there and they can be connected and hooked together like a Lego. So if you teach enough Lego drawings, here is the 100 or the 4 million Lego drawings that are out there, and the machine can learn that and pretty much generate the next Lego picture for you or the architecture. That's essentially what's happening. I think low code is making machine learning even better. And then that can regenerate code. And then suddenly a lot of the code in low code can be regenerated by. So that's, I think, is going to be very interesting. And that'll help companies get to market a lot faster. Because low code today, based on the measurements we've done, can give you speeds from 10 to 17x faster go to market. So if you are a business leader, head of marketing, head of innovation, head of digital, head of VP or CTO, VP, some business unit, you're looking at, like, you care about how quickly can I get something to market that my consumers will love, and they would really continue to use. So this low code gives you a paradigm where you can go to market faster. But with low code powered by AI, where it can automatically generate itself, it takes it like another order of magnitude faster.
Wow, that's really interesting. I when I think about what you just described, and most of these pieces that you talked about are already here. It's not like we're projecting out in the future. How will all this influence traditional organizations? Or what do retailers need to be doing today to prepare for this? Because I don't think we're talking about a 10-year adoption pattern. I think we're talking about a far faster adoption pattern than that. So what do traditional retailers and traditional organizations need to be doing today to take advantage of all this?
See, I think a couple of things. One is, of course, read up on a lot of low code because knowledge is power. Today, if you go to our website, iterate.ai, you can see a lot of use cases on low code. It's true for every software vendor who's providing low code capability. You can read up. And even if you just Google retail applications powered by low code. So today, we've seen we can power things like recommendation, commerce engines, buy online, pick up in store, license plate recognition, scan and go, endless aisle, POS capable communities, social selling communities. All these things can be powered purely through low code. So the thing is to learn a lot as much as possible. The other is to talk to experts in this industry in low code. The other is pick a few use cases, because I think what happens is sometimes when something is really new and then there is this, natural human tendency to get overwhelmed and try to do the perfect thing. Don't wait for the perfect thing. Like Amazon is, of course, it talked a lot everywhere. But I think one thing I really like about their paradigm is, I think it was Bezos, said previously, we make decisions based on 70% of the information. Pick a few use cases and then especially the ones that are low hanging. Because one of the problems in this thing, I think interesting, Jeff, is traditional companies always have a problem of identifying what an exact MVP is, a minimal viable product is. The moment you give an idea of a minimal viable product, within 3 meetings, minimum viable product will become a full-featured product. Because it's very hard for leaders and players in the industry to say, okay, I'm going to do a bare bone skeleton. And then the doubt of, if it's a bare bone skeleton, nobody's going to use it. But I think you figure out how to work through those temptations and pick a few use cases and then build a few things very quickly with low code, a minimal viable product, test the market out. And one thing that's really interesting with retailers is retailers are very good with testing. Like it is an online paradigm is all centered around A/B. Test a lot, pick something small, test a lot, keep iterating, keep adding, and then you get a lot going. And then we've had, customers who we started with one application. Now we have 14 plus applications running inside that within a matter of years. So I think it's totally possible. You can access, but the idea is to learn, pick a few use cases, and then do the smallest thing fast as possible, and then iterate on it.
Very interesting. So you're really not advocating for a rip and replace. You're advocating for a very small scale project to practice on and learn.
I agree.
Wow. Interesting. Sounds like we really need to do a conversation around how a retailer needs to have an innovative DNA. That sounds like maybe that's a conversation for another day. Brian, as always, very interesting to hear about low code. I remember years ago when you first started pitching me on low code, I thought you were crazy, and yeah, you're crazy like a fox. So thanks again for all the good information, and we will continue the conversation.
As always, Jeff, thank you. It's awesome talking to you. And I think we are in the cusp of a revolution, or already in the middle of it. I think we're just going to see more.
All righty. See you later.
Take care.
Thanks for tuning into today's episode. For more info, refer to the pod notes below. If you enjoyed this episode, please consider giving us a 5-star rating and review. It really helps us grow. I'm your host, Jeff Roster, analyst at large. If you want to connect, follow us on Twitter at JeffPR or at BrianSathanation, or connect with us on LinkedIn. Visit my website at roster.retail.com or Brian's at iterate.ai. Until next time, stay safe and have a great week.